Mentally Math!
Let's get mental!
Alright. Gonna give you a few minutes to get out in front of me. As per the usual routine. So I'm sure you're getting started. Okay. Sure you're speeding right along getting those done. Yep. All starting these. Sorry?
What's that sound?
That sound. You mean the heater?
Yeah, it kind of looks like it's generating. Yeah.
Okay, I think that's the heater. That seems pretty warm in here. I'll turn it off. Now I'm sure people have had plenty of time to get ahead. Alright, let's see. I can look at this as 1,000 plus 200 plus 30. Yes.
1230.
1,230. Oh, interesting. Okay, so for B, this is actually a very strange way of saying 4 divided by 1,000, or 3 boingies to the left, boingy, boingy, boingy. So that would give us 4 thousandths. Okay, and C, nothing fancy there. Just you could reduce 15 twentieths to 3/4 and 3/4 of.
I'm so sad. There's no estimation.
Oh, I'm sorry. I'm sure we'll be back again someday. Maybe. Actually, I'm not really sure. Okay. All right, then. So there are 1,000 milliliters in a liter. So half of a liter would be 500 milliliters. Oh, I'm feeling so edgy today. Okay. Then 109 squared root of 196 is 14. I guess we're supposed to have that memorized.
Yeah, I don't know where we did that, but I had it memorized.
Okay, cool.
I remembered it from a math lesson.
Then 1/8 of $24 is $3, and 3 times 3 would be $9. Right, okay. And what type of triangle has two equal sides? As I was saying, what type of triangle has 2 equal sides? We could all say that together. Ready? 1, 2, 3, and isosceles triangle.
Totally happened on the first try.
I'm not gonna do that off the top of my head right now. Okay, so what they're saying here is, instead of multiplying 50 times 28, which actually does not seem very hard, but I guess it's even simpler if you double the 50.
That's what I did for A, except I divided
and divide the 28 in half, so that gives you 1,400.
I swear.
That's my edgy zero.
Edgy zero.
Edgy. I'm in the edgy zeros today because I'm so totally cool.
Mr. Frederick, I did
What?
that for A. Yeah, I did that for A.
All right. Okay, so lesson 63, symbols of inclusion. So, we're talking about symbols of inclusion. We're talking about things like parentheses, brackets, braces, and our examples are actually pretty simple. They could have gotten a lot more complicated than these. But the thing to remember is that you find the symbol of inclusion that is the furthest sort of into the middle of things, if you think of it that way. And so if we So if we look at this, we can say, okay, well, that's the whole thing. And then here's kind of another layer. And then there's another layer, right? So kind of the one that is the, whoops, actually that probably should have been, oh, I got a bracket there. So the one that would be the furthest one in would, in this case, would be the parentheses.
Would be 10.
Right, so our order of doing these, so this would be my step 2. And then now I can do my brackets. That's my next symbol of inclusion. And simplify that down to 25. Ta-da! That's pretty much the lesson.
Wow.
Mostly. Okay, but we do have a couple of things to review here. Oh, hey, look at these vertical bars. First of all, can we have somebody just explain what is now we're going to talk about these as a symbol of inclusion. However, just straight up, what's the rule for these vertical bars? What do they mean that you're supposed to do with them? Yes.
If there's a negative sign, you have to take that out.
Okay, so if there's a negative sign, if the result is going to be a negative number in this case, the value represented is going to be a negative number, then you just take away the negative number, and if it's not a negative number, then you just leave it the same.
Okay.
And we call this whole thing what? Absolute value. Very nice. Okay, wonderful. And absolute value does function as a symbol of inclusion, so that would make this the furthest one in, right? And then going outward, and then further outward. Okay, so here, I'm going to give you a minute just to do this yourself. Just check this up with me. Does that answer your question adequately, Anne?
Yeah.
Okay. Yeah, you treat it as another symbol of inclusion, and you look at it the same way as the other. Is you know, how far in is it? And this one happens to be the furthest one in.
So,
yeah.
Based on the symbols of inclusion, does it matter where? So wait, I thought it just wherever there's a parenthesis, you have to do that before the square bracket.
Ooh, no, it depends, but it would appear, looking at this, that they are using the brackets as a further out one. Like, they're not doing it, like, we're not...
Oh, so if they're like side
like,
by side,
I don't think we're seeing anything like... Right? We're not, I don't really see that. However, if we did see that, it would mean we still would do the bracket first, the parenthesis second, and then finish it off with the whole thing. Does that help? But that doesn't seem to be a way that these are being set up, though.
Yeah, and if they were like side by side, then you do the parentheses first?
Just the further one in. Whatever that happens to be, but it looks like they are putting the parentheses as one that is further in than the brackets.
Right.
Well, our conversation about brackets and braces, or about symbols of inclusion at all? Okay, well, so if you need to be spending your class time doing that with a mechanical pencil, you should probably just grab one of the pencils I've got and use that instead. And do that on your own time. Okay, so symbols of inclusion are things like parentheses, braces,
So you do
brackets.
the faces.
The
faces. You're getting much better.
Oh, am I? Thank you. I appreciate that. So those are things like this, but we are also going to include our horizontal bar, our vertical bar, excuse me, that
Order they go.
what you do is you look to see which is the kind of the furthest one into the middle of the problem.
Oh, okay.
And you do those first. So say back here, it was the parentheses and then the brackets, and then we finish it off there.
Oh, that's not hard.
Okay, so I'm gonna show this one out. So in this case, the one furthest in is our absolute value. So I'm gonna do that one first. Okay, cool. So I can look at this and go, well, this would be -2. However, we're talking about absolute value, so that is just going to be 2. But we are subtracting it, so it does actually end up being a value of -2 again. Okay. And this works out to be pretty simple because -2 plus 2 just kind of leaves our 8 hanging there. Just chillaxing. Okay, and then we can just simplify that down to bar.
Wait, Mr. Pritchard?
Yeah.
I thought it was like, after, so 8, I thought we did the addition first, so like 2 plus 2.
Oh, no. Addition first? No. It's addition and subtraction are in the same category,
Yeah.
and you do them from left to right.
Oh.
And it's the same thing as with multiplication, division. Those are kind of considered just the same category. So you would just do those left to right. You wouldn't prioritize multiplication over division. You wouldn't do like, oh, multiplication first and then division afterwards. It just depends on what order they're going in from left to right. Yes?
Plus, in this example, you need to find out what that number is to do because then it'll just be 8 minus plus 2.
Right.
You can figure out what the number
Which
in
that-
between is.
that just ends
Otherwise,
up
you
being-
can't really figure out the problem.
Yeah,
Right.
I thought it was 8 minus 4 is 4, and then 12 minus 4 is 8.
Yay.
Because they did the addition first.
No. Nope. Just go from left to right, and you do not prioritize addition over subtraction. Okay, good.
Wait, what's left to right?
Like, starting from this side and working your way to the right. Okay. Okay, so once again, pretty simple, except the rule to remember here is that you do the top and the bottom separately before you ever try to divide them. Right? It is a division problem, but that's the last thing you do is after simplifying everything else. Yeah? Absolutely need to do order of operations, yes. So the top part, there are no symbols of inclusion, you just do order of operations. So we do our multiplication first. So my first step in simplifying would be 40 plus 30 minus 7. And then I do have symbols of inclusion on the bottom, so I do those first. So it'd be 10 minus 1.
Mr. Mike,
Yes.
lucky for me, I just did this yesterday with my mom, so
Oh, right
it's
on.
a lot better.
Fantastic. Okay, and then I can simplify this even further to 4 plus 30 minus is 34, then minus 7. So then that would be 27 over 9, which works. Well, wait, you do addition first. Well,
Multiplication first.
I did multiplication
Sorry,
first.
I meant, addition before subtraction.
No, you just go from left to right. So I did 4 plus 30, got me 34, then minus 7 was 27. So you just go from left to right if all you have is addition and subtraction. They're sort of just in the same category as far as order of operations goes. And once again, same with multiplication and division. Is you don't prioritize one over the other, and then that.
Exponents and exponents.
Sorry.
Like exponents. And
Right. And then that gets us to 3, and that's the lesson, guys.
That's it.
That's it.
All examples.
That's all these.